Hey guys, it's Rishi once again, and today we're back with similar shapes. So what are similar shapes? Now, two shapes are said to be similar if they are exactly the same shape but different in size. Now, scaling all the lengths of the original shape can create a similar shape, and this means that they have been enlarged or shortened in the same proportions, and we call this the scale factor. Now, scale factors ensure that a shape stays in the same proportions when the size is changed. And this may be important when resizing photos or company logos, just to ensure that the image does not become distorted. So now in today's video, this is going to be focused around geometry and measure. And as mentioned, when a shape is enlarged, the image is similar to the original shape. So it's the same shape, but a different size. So again, as you can see in question number 1 here, these two shapes are similar as they are both triangles, but one is an enlargement of the other. So I hope that this video will provide you with a clear insight into how we can work with transformations by changing the size or position of shapes, making sure that we can find out the scale factors, whether they've increased or decreased the size of a shape. So without further ado, let's get started. Question number 1. AB is parallel to XY. And the lines AY and BX intersect. So as you can see, they intersect here. They've given us certain measurements. As you can see, AB is 6 centimeters, XB is 12.5 centimeters, and XY is 15 centimeters. So work out the length of B to P. So that is now this length here that we need to calculate. So as I mentioned, these are two triangles, but we now need to work out the scale factor in order to see exactly what the length of BP is. So how do we go about doing that? Well, the first thing that we see is that 6 centimeters and 15 centimeters are both in the same position. So we now need to divide 6 by 15 in order to get our scale factor. So what do I need to do? Now, I need to have 6 multiplied by something, which will then give me 15. So the best way to do that is to have 15 divided by 6, which again, we know they're both divisible by 3. So 5 over 2, which then gives us 2.5. So we now know that we have to multiply the smaller triangle by 2.5 in order to get the larger triangle. And that is our scale factor. However, if we're going from the larger triangle to the smaller triangle, we then know we need to divide by 2.5. So now we've gone ahead and done that, we can simply work out BP by finding out the same position here, which is 12.5, and we're going to divide this by 2.5 because we're going from the larger triangle to the much smaller triangle in order to get BP. So if we go ahead and write this out, 12.5 divided by 2.5, that would give us 5. So we now know that B to P is 5 centimeters. And there we are. So let's go ahead and review this once more. So what do we see? Well, the first thing we see is that we have two triangles, and one is much smaller than the other. And now we need to find out how we get from one side of the triangle to the other. And again, please remember that these are both the same, they represent the same sides, but one triangle is much larger than the other. And then we found out that in order to get from the smaller triangle to the larger, we have to multiply this by 2.5, or simply divide this by 2.5 if we are going from the larger triangle to the smaller. So now we've gone ahead and done that. We found out our scale factor is 2.5. I then do the same with my 12.5 and my B to P. So I have my larger triangle, 12.5, divided by the scale factor to get the smaller triangle, which is 5. And there we are. Perfect. Let's now dive into question 2. So again, BE is parallel to CD. So as you can see, BE is parallel to CD. And they've given us, again, a range of different values and measurements. And now we're calculating the length of E to D. So again, as you can see, we've got a much larger triangle as well as a smaller triangle. So let's go ahead and break this apart. So we have our smaller triangle, which is going to take the measurements 9 centimeters, 6 centimeters, and I'll label this as B to E and A. We then have our much larger triangle. And with our larger triangle, we know it's 7 centimeters between C and D and 12 centimeters between C and A. So now the question is, how do I get from one side of the triangle to the other? And again, I'm going to only highlight the same areas. So we have a 9 centimeters, which also mimics the 12 centimeters. So now the first thing I'm going to do is go from the larger triangle to this smaller triangle. So again, 12 divided by something gives me 9 centimeters. So what I'll simply do is, in order to get my scale factor, SF, I'll have 12 divided by 9, which is equivalent to 4/3. So now I know that my scale factor is 4/3. So now moving forward, I'll now go ahead and I'll take my 6 centimeters and I'll multiply this by 4/3 in order to get the larger side. So now I know that 6 times 4/3 will give me 8 centimeters. And that is because 6 times 4 is 24, and 24 divided by 3 is 8. So now I know that the largest height of the triangle is 8 centimeters. But now I've gone ahead and done that, we know this entire length here is 8 centimeters. But if we have 6 on one end, I wonder what the small side will be. And in order to find that out, we simply need to subtract them. 8 take away 6 gives us 2. So now we know that the length of ED is 2 centimeters. So I hope that was clear. How I've broken down the larger triangle into 2 triangles and then calculated the scale factor before working out length E to D. Marvelous. However, the second part states calculate the length of BE. So now we're working out B to E, which is just here. So now this makes things much easier because we now know our scale factor is 4/3 and we know the larger side is 7 centimeters. So if the larger side is 7 centimeters, all we need to merely do is have our 7 divided by 4/3, which again, if we use our keep it, change it, flip it, we'll have keep it as 7, change it into a multiplication, and flip this into a 3/4. We can then multiply this out, which is 21/4, or we can say 5.25. So now we know that our B to E will then be 21/4, or 5.25. And there we are. Magnificent. I hope that was now clear. Let's go ahead and move over into the next question. Question 3. So in question 3, I hope you've now got a basic insight into what is required when answering these questions. So in this question, it seems that we need to calculate the length of CD. Now, we already have 5 centimeters, which is already very useful for us. So we know that we must multiply 5 by something in order to get C to D. So let's take a look at what that could be. So the first thing we're going to do is find a match. Find 2 sides that are the same, but are for different triangles. So again, we can take a smaller triangle, which can be the first half, and then the larger triangle, which can be this entire thing here. So let's go ahead and draw these out. So we have our much smaller triangle, which is the above triangle. We have 4, 4.8, and 5. So this is mimicking this triangle here. We then have a much larger triangle, and that larger triangle is going to mimic the entire thing. And what we have so far is 4 and 6, which gives us 10. So that's the total of these 2 here. And that's all that we're given here. But now what we can see is that we have 4 from this side and 10 from this side. So the question is, what do we multiply 4 with to give us 10? So now we know that we can simply have 10 divided by 4, which is 5 over 2, and that is 2.5. So now we know that we have to times 2.5 to get 10. So our scale factor here is 2.5. So scale factor equals 2.5. Now we've done that, we can simply multiply 5 by 2.5, which then gives us 12.5 centimeters. And that is our answer there, 12.5 centimeters. So again, let's quickly review this. I've split up the triangles into 2. I've then found one side that is the same for both triangles. And in this case, it was 4 and 10. I've then divided 10 by 4 to get me my scale factor, which is 2.5, and then used that and multiplied it out with my B to E to get my C to D, and there we have our answer. Perfect. But now we have a part B here, and that is to calculate the length of E to D. So now that is this section here. So we now know our scale factor is 2.5. So what do we need to do? Well, we already know that we have 4.8 as part of the same side that we're looking for. So now because we have 4.8, we need to simply multiply this by 2.5, which will then give us 12 centimeters. So we now know that the entire thing here is worth 12 centimeters. But now if we want to work out E to D, we simply need to have 12 minus 4.8, which then gives us 7.2. So we now know E to D is 7.2 centimeters. So now let's go ahead and write down 7.2 centimeters. And that again is by following A to D, which is 4.8 times 2.5, which gives us 12. And then 12 take away 4.8, which gives us 7.2 centimeters. Marvelous. Okay, let's move over into question number 4. Keep up the great work and don't forget to pause the video. Attempt the question and then press play to see if you've got the correct answers. So feel free to pause the video now, attempt this question, and then press play. But for those who would like me to continue, let's carry on. So the first thing we need to do is find out 2 different sides which account for the same. So what we need to do here is simply find out one side that is the same. So what we need to do here is simply find out 2 sections that are the same for both triangles. So now as you can see here, we have our 8 and we have our 12. Now that's in the same position, but of course it is an enlargement as we have 2 different values. But now what are we going to do? We're going to take our larger number and divide this with our smaller number. And that there would give us 3 over 2 or 1.5. So we now know this is our scale factor. We're then going to go ahead and take 26, which is a smaller triangle, and we're going to multiply this out by 1.5 to get the larger triangle, which is going to be 39. So now we know 26 times 1.5 is 39, and that is our answer. We can then take this a step further to calculate the length of BC. Now, if we're looking at B to C, we now know we're going from a larger triangle to a smaller triangle. So in this section, we will divide by 1.5. So 45 divided by 1.5 will give you 30. And again, if it's easier for you to do this in a fraction, feel free to have 45 divided by 3 over 2, where you keep it, you change it, and you flip it. So 45 times 2 is 90, divided by 3 is 30. And there we are. 30 is our answer. So again, that could be your method 1 or that could be your method 2. It still will give you the same answer. Remember, keep it, change it, flip it. You're keeping the 45, we're changing the divide to a multiplication, and then you're flipping the 3/2 to a 2/3, before then finally multiplying out the numerator and then dividing it by the denominator. Marvelous. Okay, let's move over to question 5. We've now been given 2 triangles and a set of measurements, and we need to calculate the length of CE. So that is this length here. So what's the first thing we're going to do? Well, we're going to split up the triangles. And so we'll have our smaller triangle and we'll have our larger triangle. As you can see, we have 6 at the bottom here and 9 over here. So again, we need to have 9/6, which can be seen as 3/2 and 1.5. Now we know that is our scale factor. And we need to get C to E. So what are we going to do? We're going to take our smaller side, which is 8, multiply this by 1.5, which gives us 12. So now we know that C to E will be 12 centimeters. So again, I start off with my scale factor, and I know that we have 9/6, which is 3/2. I then take 8, which is the smaller side, and times this by 3/2, which gives me 12 centimeters. And then we go for the second part, which is the length of BC. So now, in order to get the length of BC, we now know we're going from a larger side to a smaller side. So again, we'll take our 13.5 here, and we'll simply divide this by our scale factor. Again, we can have our keep it, our change it, and flip it. So keep, change, flip. And that there will give us 9. So now we know that we have 9 centimeters, which is going to be B to C. And again, please remember here, from a larger point to a more smaller point, we divide by 1.5. But from a smaller to a larger, we times by 1.5. Beautiful work. Let's now move into question 6. So in this specific question, we're now faced with a ratio, which is A to B and A to C is 1:3. So that means for every 1 that AB is, AC will be 3 times more. So what are we going to do here? Now the first thing I'm going to do is take my AC and understand that we're going to have 5, which is your A to B, and we're going to times that by 3. So 5 times 3 is 15. And the reason I'm doing this is because it's 3 times more than A to B. So now we know that A to C is 15 centimeters, while A to B is 5 centimeters. So now I know that the larger one is going to be 15 centimeters, which means B to C is going to be 10 centimeters. But now they're asking us for C to D. So now I know my scale factor is going to be timesing by 3. Let's now go ahead and multiply our 4 by 3. And that gives us 12 centimeters. So now we know the length of CD is 12 centimeters. So again, I've used the ratio to find out the scale factor, which is 3. And then I've gone ahead and multiplied it out from BE in order to get CD. And then we've also done part B to get the length of BC, which we now know is going to be 10 centimeters because the entire A to C is 15. But if we subtract 5 from here, we'll end up with 10 centimeters. So simply 15, take away 5 equals 10. Marvelous. Okay, you've been doing really well. So let's now move over into the final question here. So we have a 20 euro note, which is a rectangle 133 millimeters long and 72 millimeters wide. And we also have the measurements for a 500 euro note. So we now need to show that the two rectangles are not mathematically similar. So the first thing we need to do is work out the scale factor for the length. So we now know that we will have 160 millimeters over 133. And that there is the length and the length being divided. We then do the same with our width and our width. So if we have the scale factor for our width, it's going to be 82 over 72, and that can be simplified to 41 over 36. And now we need to prove that this is not mathematically similar. Now, we already know that the scale factor for the length is not equal to the scale factor for the width. And what that means is that in order to divide 41 over 36 and 160 by 133, the answer should be the same. But because the answer is not the same, we now know that the scale factor for length is not equal. Therefore, they are not similar. Marvelous. And that there brings us to the end of our session. I hope this topic has been useful. We've gone through a range of different questions, which has outlined all of the different techniques that we can use in order to calculate the scale factor using a one-step method as well as your multi-step methods. Now please don't forget the steps that we have taken here, where we are going from a smaller number to a larger number, we have to multiply by the scale factor. Or when we do the reverse, going from a larger number to a smaller, we need to divide by our scale factor. I hope this video is clear. Don't forget to share and subscribe to our channel, where you can be notified of new content as soon as it is uploaded. Remember, improvement is only made by repetition, so keep up the great work, and I'll see you